Okay folks, welcome back. So this is video number 13 in this series where I am using the R programming language for data science tasks and data analysis tasks. So in the previous videos we've been covering some R basics around the types of function you would use to tidy and wrangle your data to get it in some sort of shape where you can do some type of analysis with it or some sort of plotting. So we looked at rename in the last couple of videos. I think we looked at renaming and relocating and using the mutate function. What I'm going to do in this particular video is look at how we could, if we've got a data set, a data file where we've got some categorical variables, how we can divide our data into groups represented by those categorical variables by using the group by function. So group underscore by would be. So that's going to separate the data set that we're using into some sort of meaningful groups on a categorical variable or something like that. There's a couple of other things I'll demonstrate as well whilst we're here and highlight some things, some common issues you might encounter when using this. I said in a previous video, I kind of previously created a project to kind of store all of the scripts that I'm using and for this particular series around R basics. I think I called it R data wrangling or something like that. And if you look up here in this top right corner, you can see R project none. So I'm not currently in any project. And I believe what happened, I think I explained this in a previous video, is there was some sort of technical issue and my project has been corrupted. So I've just been creating individual scripts and running them, which is fine, it works okay. But what you will need to do if you're doing that type of thing, if you've not created some nice self-contained project like a sandboxed environment, is set the working directory each time you want to run a script or call certain files that are in a certain location, like a particular folder on your computer. And I've shown previous ways to do that. So one of the ways was if we look in the bottom right window here, you see I'm in the files kind of tab, and if I click on the little gear icon, the settings icon, you can see we can set as working directory, that type of thing. So what I would need to do if I wanted to use this GUI drop down interface type of way to set the working directory is kind of use my folders to navigate to the folder I want to be in. But there's another way to do that just using syntax, and that's the function or command or method you'd use is like set working directory or set WD, and then in parentheses you pass the relative path as a string within quotes. So you can see that's what I've done here on line 70. So I've got set WD, and then I've got double quotes, in parentheses I've got double quotes, and I've copied the path to the folder that I want to go to. So it's kind of this R data wrangling folder, which is where the data sets and different things that I want to use are. So if I run that, what you will see is if you look here in the console, you see I'm using R 4.2.3, and you've got this little, you've got the tilde and then a kind of forward slash character, and that is currently telling us which folder our working directory is in, and it's kind of just this global working directory, I believe. So if I do Control Enter and run the set WD command, you'll see that has now changed here. If I kind of highlight it with my cursor or put my cursor underneath it, you can see it's changed it to this path that I passed as a string variable. So I've used syntax to set the working directory essentially. So it's a useful thing to know. And there's another command, I'm not going to run it now, but if you kind of don't know what your working directory is, there's a command which is get WD, that type of thing. And I believe if you run that will print to the console below what the working directory is you're in, so you'll know if you're in the right place or not. Okay, so let's get back to what I was actually going to do in this particular video, which was demonstrate how to group your data based on a particular variable, categories of a variable, and I'll use a couple of examples. And grouping data is useful if you then summarize it in some other way. So you'll see what that means in a second. So what I'm going to do first of all is I'm going to load the tidyverse. I'm using library tidyverse. As you know from previous videos, that is a package which has lots of other packages within it that are useful for plotting and wrangling data, so tidying your data up. And you can see there's some of them. There's ggplot, dplyr, tibble, tidyr, things like that. And we get this, you can see in the console there, that's loaded. I've got my command line prompt back. And we get these conflicts as well, sorry, there. So you can see there we've got filter and lag are functions that have the same name in a couple of different packages. So it's just making us aware that we need to get the correct syntax so it knows which filter we want to use, which lag we want to use, that type of thing. So what I'm going to do is, first of all, I'm going to call the NYC flights package using library. So if I run library NYC flights 13, and then if I do view on the flights data set. So if you remember from a previous video, we looked at this particular package and the data set contained within it. It's a massive data set with all these all flights that took off from New York City airports or arrived in New York City airports in the year 2013. And I used the view command, and you can see there it's given us a pop-up of the main variables. And it's the first kind of 7 rows. You can see there are 336,776 rows in this data frame and 19 columns. Really big data set. But I was going to just use this first of all to demonstrate using the pipe operator how to use group by. So we've got this data frame here, and we've got a number of categorical variables here. So month. Obviously, the number represents the month of the year, so 1 would be January, 2 February, 3 March, etc. And there's probably some others here as well that are categorical variables, such as origin, destination, things such as that. Probably even the date. You could divide the specific date into categories. But what we'll do is, if I go back to my script, we'll just group by the month category. So that should give us. Notice here I'm not saving this. I'm not assigning it to a new object, so we won't get a new object in this environment here, and it will just print a tibble to our actual console window. And you can see that's what it's done there. It's given us this little. It's given us a kind of quick breakdown of the data frame as a tibble, essentially. It's kind of, it looks similar to that, but obviously not a nice HTML spreadsheet version of it. But one thing to note is here we've got this groups month 12, so it's kind of grouped the data. It's given us a grouping of the data using month, telling us it's got this particular item has the data grouped into 12 months. So let me show you something similar, and I'm going to import a data set to do this. So I'm going to import the Titanic data set, because that's also a big data set, and it's a useful data set because it's got a mixture of numeric and categorical data. I'm going to save it as a new object called data frame. So let me just run that command, and you can see there DF's been created, 891 observations, 12 variables. Let's just look at the header for this new DF data frame. You can see we've got a number of different variables. Okay, and we can do view on it as well. That'd be useful because we'll come back and look at it. And there it is, view. So categorical variables, survived, yes or no, passenger glass first, second, third, things like that. So we've got categories that we might want to group our data by. And if I go back to the script, that's what I'm going to do first of all. I'm going to take our DF data frame, I'm going to use the pipe operator, and I'm going to group by P class. And I've spelled it exactly as it is saved as on the data frame. So capital P, lowercase class. If we look at DF, we should see that that's how it's saved. Okay, so I was going to recognize that's what the variable we're talking about. If I run that it'll do a similar thing to what we saw before when we ran this on the flights data set. So we've got a tibble, and notice I've not changed the object, so I've not shaped it as a new object df2 with the grouping saved or anything like that. So all it's done is really save an image of the data frame with this command that we've just run. So it's printed the tibble, the respective tibble for this command to our console. And you can see we've got groups passenger class 3, but if you look at passenger class, we've got 3, 1, 3, 1, 3, 3, 3, and if we look at it on our data frame, it's exactly the same, 3, 1, 3, 1. So it's kind of, you'd like look at that and think, well, it's not really done anything useful, or it doesn't appear to have, because it's not kind of rearranged the data, so it's obviously in categories or anything like that. We know it has been grouped based on passenger class because we can see there it's given us that in the printout. But what I'm highlighting with this is that this group by function is most useful when you combine it with some sort of summary of the data. Okay, so the most common one or a very common one you will see it combined with, is the summarise function, and then you can pass some sort of summary statistic, such as a mean or a median or something like that for your variable, as an argument. So let's do that with this particular Titanic data frame. I'm gonna basically combine the group by of the passenger class with summarise. So I'm going to take our data frame, then we're going to pipe it into group by. So take the data frame and then group by passenger class, and then another pipe saying, and then summarise. And I've created this kind of new variable name, so to speak, or this new object, and I've set that equal to the mean of the fare variable. Okay, so you can see we've got it printed here. We can look on the data frame. In fact, we have this variable called fare. Okay, so hopefully it's obvious what I'm doing here is I'm saying take the data frame and separate it into groups based on passenger class, and then for each passenger class tell us what the mean fare was. So let's run that and see what sort of output we get. And there you go, what we see is it's printed as a much smaller tibble because it's done the actual summary statistic that we wanted it to do. So it's printed our 3 passenger classes, 1, 2, 3, and it's printed the average fare that we asked for. So it's taken the mean fare, and you can see there. So the average fare for first class was 84.2. Maybe that's dollars or GB pounds or something like that, pounds sterling. The average fare for second class passenger was 20.7. And the average fare for a third class passenger was 13.7. Okay, so that's pretty good. That's quite useful. One of the most useful summarise functions, or certainly one that you pretty much need to know if you're looking at differences, you're looking at categories and differences between them or things like that, is you're often going to want to use the summarise function to obtain counts of observations in each group. And to do that, you can the argument you would use is the method would be n with parentheses. Okay, you can see that here. So what I'm going to do here is I'm going to run pretty much the same command as previously. So I'm taking df and then I'm grouping by passenger class, and then I'm using the summarise function, and I'm saying return the average fare, which is going to be the mean. So the function I'm using, or the method I'm using here, is the mean. So work out the average, the statistical mean of fare, and then I've put a comma and then another one. I'm saying return n, which is going to be n, and I've not had to put anything in parentheses. I will know what it is we're asking for here. We might want counts of something else. But what this will return is it'll give us what we got below here with our different passenger classes and the average fare for each. But it'll also give us a count of how many passengers there were that were first class, second class, third class. Okay, so let's run that and see what happens. Now you can see. So so interestingly, you've got another tibble. It's got the n column appended to it Still got our fares, our average fares for the 3 passenger classes, but you can see now there were 216 passengers were first class, 184 were second class, and 491, or the vast majority, were third class passengers. So lots of people paying the cheaper fare. I'm going to just change that because I can see a typo. All right, so there was one other thing that I wanted to illustrate, and I'm going to return to the flights data to do this because I know it will happen with that data. So a common error that you might see or that you might get is when you run a command like the ones we've just done, where it's a kind of grouping by and then summarizing, getting a mean, getting a median, getting some other summary statistic, you might get a table return that's not very useful or informative. So let me run this. So what I'm doing is I'm taking the flights data and then I'm grouping by month again. Okay, so it'll give us 12 groups, one for each month of the year. And then I'm summarizing, and what we're going to do is we're going to ask for the average delay. This is just a name I've chosen and specified. So the average delay, and that's going to be the mean of the departure delay. So let me go back to the flights variable. We've got this departure delay. It's a figure, it's a number there, and what we're doing here is we're just working out the mean value for departure delay and calling that average delay. And let me run this and you'll see something quite interesting. Okay, so I've not saved it as a separate object again, but what we're seeing is it's returned this table, and it's returned that 12, obviously 12 rows, one for each month, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But in terms of the delay, average delay, it's returned NA, not a number, or missing essentially, for every single month. But we know, I mean, just by looking at that, we know we've got some values for like month 1, 2, 4, 2. So what's going on here exactly is when we've run this, there are some missing values. I'm not going to scroll through because it's a huge data set, but there are some missing values in this for each month in this data frame. So there are some NA values, and our base effectively doesn't know how to deal with them, or it doesn't know how we want it to treat them. So it's not able, so it tries to calculate an average, but it's not able to because it's got some values in there that are not numbers essentially. So it's returning an NA for each one, for each kind of month in terms of the delay to departure. So what we need to do to rectify this is, this is kind of, it's wrong essentially, it's returned the result that is wrong and confusing. So, but to overcome this, what we'd have to do is provide an additional argument to remove the missing values. So we'd have to coerce it essentially to remove the missing values and then work out the mean delay without those NAs present for each in the data frame, in the variable essentially. And this is done using the syntax na.rm, which stands for NA remove, and setting that equal to true. Okay, so let's run that again. So we've got flights, and then we're grouping by month to give us our 12 months, and then we're summarizing, and we're saying we want it to return for each month the delay, and the delay is going to be the mean departure delay. And with this time you can see I've put a comma and then I've added this additional argument that we needed here. So na.rm equals true. So what we're doing is saying to R, remove the missing values, essentially. Let's run that again, see what happens. Now you can see we've got the average departure delay for each of the months of the year. It's obviously highest in 2020, months 6 and 7. So that will be June and July. Seems to be quite high values there. Okay, so hopefully that's useful. But some common things that you might encounter and think, why is this not working, essentially? And there's a number of reasons for it, essentially. But the one we've encountered here is we've got these missing values, and we needed to supply an extra argument. Okay, so what have we covered in this video? And I'll stop talking because it's gone on far too long already. So what we've done is we've looked at how you can group your data using, if you've got a categorical variable, you probably want to group it by the meaningful groups in the category and then summarize each of the groups. Grouping on its own is kind of limited value unless you're going to do something else with it. Often you're going to want to summarize it, work out some sort of summary statistics. So what we did here was just demonstrate that you can use the pipe operator and that useful tidyverse syntax to group and then summarize. And we just demonstrated this using the mean on for a couple of different variables. Okay, and I've also showed you how to, if you encounter problems, it's not working properly, you might have some sort of issue with missing values, and you need to use that na.rm syntax to kind of remove those. Okay, thanks for watching and listening. More of these videos soon. Not sure how many more of these kind of R basics data wrangling videos I'll create. What might you move on to soon is some data visualization and plotting, so exploratory data analysis. Okay, thanks very much guys. I'll speak to you soon.